Hey everyone, it's Mr. Anderson. Welcome back. Today we're going to talk about section 9.1.3 from our CPM Common Core Algebra text. And our goal today is to discover a little bit more of an in-depth perspective about how versatile the quadratic formula can be. We're really going to hopefully start today with a little bit of review of what the quadratic formula can do for us, and then talk about really what some of the possibilities are that we haven't explored yet with the quadratic formula. And as always, I've got some modified notes here that I've taken from our book, but let's just review where we're at. In our Common Core Algebra book from CPM, we are in Chapter 9. We're going to be looking at this right here from Section 9.1.3, and all the items in my notes today are coming from this text, including some of the algebra tiles. And we'll start with a look at problem 9-24. Okay. In 9-24, we are asked to solve an equation, solve a quadratic equation, and we can do this because it's equal to 0, and we are going to ask to solve using the zero product property. And recall, when we're using the zero product property, one of the processes there, one of the things that we start with there is factoring. Okay, so we want to factor this, and it is a really, really nice thing to be able to factor something, because it means that we're going to have integer rational solutions, which you'll see in just a moment here. But one of the things you may need to do is you may need to see this, and of course fall back on those algebra tiles. You can use the algebra tiles to build this, and that might help you get the dimensions of the area of that rectangle, and it may let you know if it's factorable or not. So pause the video right now, try to build this using algebra tiles, and I'll show you what I built in just a second here. Alright, so my algebra tiles look like this. Alright, as you can see, I've got the 6x squared, I've got negative 10, and I've got those built in, right? So here, real quick, is my 6x squared right there. Here's my negative 10, okay? But then I built 11x using some positives and some negatives, right? I've got what appears to be 15x right here, and then I've got negative 4x right here. And remember, 15x minus 4x, that does work out to be 11x. So I am okay to do that. I'm not breaking any rules. But then the factorizing comes in when we look at the dimensions of this rectangle. So I went ahead and added the dimensions as well. Oops. Try this again. There we go. I've got 3x and 2 for that dimension right here. It's this guy. Okay. And then for this dimension right here, I've got 2x and positive 5, and I'm erasing my brackets here. I'm not sure why those are disappearing, but 2x and 5 right there. And ladies and gentlemen, remember, this thing might be an x squared tile, but it is x units by x units. That's how we get the x squared, right? Because it's named after the area. So this is x and x and x and negative 1 and negative 1, and that's a clunky way to write that. So that's where the 3x and 2 comes from. Now, here's what we do with that. We take and we write that area as a product, 3x plus 5, and then, actually I think it was 2x plus 5 and 3x minus 2. Sorry about that, I got to modify that real quick. 2x plus 5, and then 3x and minus 2. And now, because it's equal to 0, this is a solvable equation. So here comes the zero product property. This is where we break this apart, because we know that if the product equals 0, that one of the factors, in this case it could be 2x plus 5 has to equal 0, or it could be the other factor, 3x minus 2 has to equal 0. Okay? And now let's go ahead and do some solving here, and we solve just using our normal rules of algebra. So I've got 2x, this is negative 5, and then I divide everything by 2, and this is negative 2.5, or negative 5 halves, right? Either way, we get an answer. This is one of those rational answers that I just commented on. It's not a nice integer, but it's a rational number. Okay, same thing's going on here. Add 2 to both sides, and then I get 3x is equal to 2, and then I divide everything by 3, and I get x equals 0.6. Repeating again, I've got two answers. I've got a rational answer as well. So I get one of these, this or that, okay? So they're solving using the zero product property. We had a rectangle that was buildable, or I'm sorry, a trinomial that was buildable into a rectangle, and so that let us know that we're going to have some success factoring. Now let's take a peek at doing the exact same thing using the quadratic formula. And folks, we've got a quadratic formula there. Oh, goodness, Anderson, there we go. Everything keeps deleting on me. Sorry about this, ladies and gents. Quadratic formula from a prior unit, or from a prior video, recall is negative b plus or minus the square root of b squared minus 4ac over 2a. This is a trinomial, a generic trinomial in standard form that somebody completed the square with and solved for x. And it gives us the ability to identify coefficients, plug in a, b, and c, simplify, and come up with the solutions. And ladies and gentlemen, the only thing we need to do is look back and identify that a is 6, b is 11, and c is negative 10. And then we plug these things in correctly. A is 6, b is 11, and c is negative 10. Okay, and if we can plug those things in correctly, we can then simplify following our order of operations that we've been working with for years now, and then come up with two solutions. We're going to see if these two things match, okay? So here we go. X equals negative b, that's negative 11, plus or minus the square root of b squared, 11 squared, sorry, minus 4 times a, which is 6, times c, which is negative 10. And I'm just going to extend that radical symbol, and this is all divided by 2 times 6. Now I like to take this in a bit of a step-by-step approach. Nothing I can simplify out front in this part, so I'm just going to leave that to be negative 11. But everything under that radical can be simplified. So I'm going to leave the radical in place for a minute, and I'm going to do all that work. Okay, 11 squared is 121. 4 times 6 is 24, times negative 10 is 240. So this is 11 squared, 121. Okay, and then it's plus, right, because it's subtraction of a negative, 240. So it's going to be plus 240. And then that's all divided by 2 times 6, which is 12. And now x equals 11, negative 11, sorry. Square root of 121 and 240. And that makes 361 and divided by 12. Okay, now here's where the calculator may need to get involved. I'll be honest with you, I do know a lot of perfect squares, but I do not know if 361 is a perfect square. So there's no shame in me relying on my calculator. And what I'm going to do here is I'm going to grab my phone, turn my calculator on. I type in my 361, I turn it sideways so I can have that radical, and then I take the square root. Turns out it's 19. So this really turns into negative 11 plus or minus 19 divided by 12. Okay, and I've got x equals here. Okay, so here's where we break this up into our two pieces. All right, I've got x is equal to negative 11 plus 19 over 12, and then or x equals negative 11 minus 19 over 12, right? You can see I'm going to have two solutions just like we did in A. All right, so that's no big deal. We do have the ability to have both parts present and relevant here. Okay, negative 11 plus 19, that works out to be 8 over 12. And 8 over 12 reduces to 2/3. Ding, ding, ding. Look at that. Okay, you can see that I'm going to be able to create that connection here. Look at that. 2/3, 2/3, right? Okay, if I want, I can simplify that, right? I'm going to have the same parts. Okay, and then I've got x equals negative 11 minus 19. That's negative 30 over 12. And if I leave it like that, it's maybe going to be a little ugly. So I might want to reduce that. And if I do reduce it, it does reduce to negative 5/2 or negative 2.5. And ladies and gentlemen, one more time, we can see that connection here. I can connect that to that solution right there. So the question in C asks, hey, did the solutions from A and B match? Yeah, they did. But notice what I did here. I solved it all the way, and I got the decimal answers right here in the quadratic formula. I could have taken that and solved it, or broken it all the way down and gotten the decimal answers. However, I didn't. For whatever reason, I left it as a rational expression. Okay. The next thing I'm going to go ahead and do here is we're going to look at 9-25, and in 9-25, you guys are going to see some problems, and the problems look a little different here. And the goal is to talk about what we can do with these kinds of things when they're not in standard form, right? Because the quadratic formula really works out well for us when we've got this thing in standard form equal to 0. But what if that's not the case? Well, look at something like A. All right? In a situation like A, I've only got a binomial. So I can expand A, and this is totally legal. You're allowed to add 0 to something, okay? If I just add in here a 0x. Okay, now look at what I did. I put that in there in standard form. I knew the x term was missing. So now I've got an A of 4, I've got a B of 0, and I've got a C of negative 121. Okay, so that is now able to be handled with the quadratic formula. If I look at B, this thing is not in standard form either. So watch this. Just do a little rearranging, but I've got to respect those signs. The 2x squared comes first because that is my quadratic term in this trinomial. All right? Then the linear term comes next, and I keep it with that sign, so it's minus 3x, and then minus 2, and that's equal to 0. Now I've got an A of 2. Oops. I've got an A of 2. I've got a B of negative 3, and I've got a C of negative 2 as well. Again, the quadratic formula is going to work here. All right? Let's keep going. C, I've got something like this. Whoa. It's not equal to 0, so what in the heck do? I'm going to take this thing and I'm going to move it over to the other side. Remember, you switch the side, you switch the sign. So if I do that, it's 15x squared minus 165x. Nothing happened there, but now it's plus 630 is equal to 0. All right? And then I've got an A of 15, I've got a B of negative 165, and then I've got a C of 630. Okay? Ladies and gentlemen, the last one that we're going to look at here is letter D. Letter D looks like this. And how come this thing isn't in standard form? Similarly to C, you can see that we've got it not equal to 0. And so I've got to move this, but I'm going to take it and I'm going to move it over, and I'm going to move it between my quadratic term and my linear term. So this becomes 36x squared. It's going to be minus 60x because, again, oops, you switch the side, you switch the sign, and then plus 25 equals 0. Okay, so A is 36, B is negative 60, and then C is 25. So ladies and gentlemen, do not abandon hope just because your quadratics are not in standard form. You might have to take a step, just like I did in these problems, to get that thing in standard form. And doing a little bit of extra work to make it, to make the quadratic formula accessible is definitely worth it, because as we see, the quadratic formula works on so many things that we've done so far, whether it's factorable or not. Okay? Quadratic formula is going to be a great tool for you, and there's even things that we'll talk about down the road and in future math classes that make the quadratic formula more accessible. Ladies and gentlemen, a little bit of review preview here. Pay attention to this. Okay? Try these things. Ask questions. Let's see what kind of things the questions reveal, and if you need to, check your answers. Okay. I appreciate you watching, ladies and gentlemen. Thank you. Have a great day.